I just want to explain a few pieces of the biological process in the plants and the what happens to build higher quality nutrition. This is a topic that's not well understood or known, but is very important when we start to really have a serious conversation about quality and nutrition. There are sort of sets of orders of compounds that are built by the plant in a stepwise fashion. So the first compound that's built by the plant is sugar. Through the process of photosynthesis, you have a chloroplast. You start with carbon dioxide, water, and photons, and you build sugar. And that's effectively the magic that the plant does, the thing that's unique to plants, and what makes them so important in the overall scheme of things. Those sugars in a healthy plant, many of them, 30 to 60% of them, will be exuded out of the roots to feed their livestock, their bacteria and fungi, which then go out and access minerals from the plant, from the soil, as directed by the plant to feed back up to the plant. It's a beautiful symbiotic relationship. And those minerals are used by the plant, those minerals that the soil life accesses are used by the plant to build higher order compounds. So from simple sugars are built complete carbohydrates. From complete carbohydrates are built proteins. From proteins are built lipids and lipids and essential oils. And finally we have the phytonutrients and antioxidants and the higher order compounds being built. So this is a process that the plant goes through and effectively, in most cases, does not complete. In most cases, we have plants that are able to make it to the stage of complete carbohydrates but not be producing complete proteins, or complete proteins but not producing essential oils and lipids. In reality, when we actually grow plants, many times they experience limiting factors of basic mineral nutrition and are unable to create these complete compounds. We can determine how well a plant's doing based on pest and disease pressure in many cases, because certain pests and diseases can only attack plants up to a certain level of complexity. A lot of the soil-borne pathogens, the fusarium, the alternarias, the verticillium, those types of soil-borne pathogens cannot digest complete carbohydrates well. They like simple sugars. And so when you have a plant that's building complete carbohydrates, you generally see decrease, if not a lack of presence of those types of pathogens. The larval forms of insects, the potato bug larvae, the cabbage looper larvae, any number of larval forms of insects cannot digest complete proteins. They don't have the enzymes in their digestive tract to break down the double bond at the center of protein, so they're physiologically unable to digest them. So what that means is if you've got a potato plant that is producing complete proteins, it is no longer food for the potato bug larvae. This is very interesting and works very nicely and is part of the natural order of things. I would suggest that insects and diseases are nature's way of removing unhealthy biological material from the reproduction path. That insects and diseases are nature's garbage crew, and their job is to come in and clean up those plants that should not be reproducing. In most cases, most farmers grow plants that are susceptible to some pests or diseases. Going on from the complete protein stage, if you go up to the lipids being formed, that's really a higher level of functionality. What that looks like on a plant is the leaves looking really glossy. When the leaves go from green to a nice shiny kind of green with almost iridescent kind of sheen in the leaf surface, waxy surface, those are fats, lipids that are being built by the plant and stored on the leaf surface. And that, when you have that lipid layer being built on the leaf surface, then you have resistance to all of the airborne pathogens, the blights and the mildews. So if anybody's ever grown tomatoes that have gotten blight, or cucumbers that have gotten mildew, you're familiar with these diseases. If you had a nice waxy layer on your leaf surface, your plant would not have been susceptible to those pathogens. The final stage of complexing of compounds is the essential oils, the antioxidants, the the phytonutrients, all the phenols, there's thousands and thousands of these compounds. They correlate strongly with flavor and aroma, and when those compounds are being built at good levels in the plant, it becomes resistant to the beetles, which are the sort of the highest form of pestilence that the plant can experience. So we have direct correlation with health and vigor with the complexing of compounds, and direct correlation with quality of nutrition with the complexing of compounds, and direct correlation with pest and disease pressure with these complexing of compounds.